So this page is from the end of the most previous video, but there's one other thing to talk about for the class that this video is meant for, and that's what's called the energy density, right? So any density implies that we're taking some quantity and dividing it by some physical parameter. And usually densities involve the volume, and so that's what we'll do here. But the idea is that if I have a parallel plate capacitor, and I'll do my best to draw these plates in 3 dimensions, right? I have some sort of distance between the plates, d, and I have some sort of area on the plate. And so if I'm going to look for the volume between the 2 plates, right, this region here, the volume, and I'm going to have to put a little tail on this to differentiate it from the voltage. So the tailed V is volume, is equal to just AD. That's usually how we think about it. What I can then do is take any of these expressions of the potential energy in this region and divide it by the volume. So I could get 1/2 QV divided by AD, which is the volume. And what I've done there is I've determined the energy density, which we usually write with a lowercase u sub E. So uppercase U sub C is the potential energy for C for B Coulomb there. The lowercase u with the E is energy density. With my handwriting, it's really difficult to tell those apart. I get it. The good news is we won't see this a whole lot just yet. But in print, this is usually pretty obvious. And if there's ever a question, please just ask. No big deal if you're looking for clarification. The point of this, though, is that it can be shown. We're not going to show it right now, or even in this class at all. But it can be shown that the energy density can be expressed thusly: 1/2 epsilon naught times E squared, where E is the magnitude of the electric field in that region. So I just want to introduce this to you. It actually becomes important later when we're talking about electromagnetic waves. I want you to see it here because this is an expression that you will see again later, not just in this course, but if you take further electromagnetism courses. This is the energy density in a region of space, and we derived this in terms of a parallel plate capacitor. This turns out to be a general result. The energy density in any region of space in which an electric field exists is 1/2 epsilon naught E squared, where epsilon naught there is the permittivity of free space. E is the magnitude of the electric field. Gotta take a magnitude here because energy is not a vector, therefore energy density can't be a vector. And so I just wanted you to see this expression. Hang on to this. We're going to use it later.